Okay, it looks like it reconnected. Is it working? Looks like it. Yeah, okay, we're back up. That's so obnoxious. It like cuts up my stream and like just like boots everybody off of it. It's really obnoxious. They're using a vector for the nodes. Welcome back. I don't know what's wrong with this thing. I think I'm dropping Xfinity. They're charging me for a gig and giving me 100 megabits. And it's not even stable. We have a set of points. We want to build it such that every leaf node contains exactly 1 point. Which is not always possible, yeah. So here's your node, which is 2 by 2. All the nodes is a single array. And use array indices as nodes. Okay. That's kind of cool. That's given me some ideas. This is kind of like a heap, right? Faster deletion. You need to be able to look up the indices, though, don't you? You need to be able to look up the indices was the hard thing. Wait, do I even need a recursive tree? There's absolutely no reason I need a recursive tree, right? Am I just being dumb here? Yeah, wait. I really just need this like this partition tree, don't I? Like I need the coarsest partition tree. Okay, let me think about that. So if I just have a list of all of the agents in a chunk, essentially, if I just use a chunk system instead of a recursive system, and then I just check current chunk and adjacent chunks, right? I think that solves the entity loading problem. That does solve the entity loading problem. So The only thing I need to figure out is essentially like the vector. You need something like the C++ vector, don't you? Which can be... what's the data structure for a C++ vector? Dynamically resizing array. List is a doubly linked list. And a set is a... that's actually really weird that a set is a red-black tree. That's funny. This is what I want, is I want a list. I want just a doubly linked list. I really don't want to have to use the C++ API. It doesn't even need to be doubly linked. But yeah, you need some data structure that you can... Actually, a doubly linked list is not great, is it? See, the problem with... wait, does this work? Okay, I can see in my head how this works algorithmically, but from just an implementation perspective, this is pretty tricky. Welcome back, YouTube folks. We're online. You know what? Since I've just kind of been sitting here thinking out loud for a bunch, I'm going to diagram all this because there's kind of a cool algorithmic thing that you can do here. I'm sure this has been done in other games and stuff, but like this is... I mean, it's an interesting and very, very performance sensitive thing. So let me draw this out for you guys. I wish there were a link I could just paste in chat for this. This would be funny. Okay, anyways, so you have your game board, right? I'm going to draw this over here. Now, right now, the way that I do this game board, I just divide it up into tiles. So, I mean, this thing is tiled. You can just pretend each of these little gray or white cells is a tile. And it's pretty darn expensive to do nearest neighbor checks. Not nearest neighbor checks. It's pretty darn expensive to compute, like, all of the agents within a 5x5 around you, because you have to look through all the individual tiles. So what I could do is I could partition this up into chunks. Like this. And then let's say that you're right here somewhere. Your agent is here. Then